We are looking at inverse trigonometric functions. First one we're going to look at here, the blue wave, is a sine wave. And I've got my horizontal line. Oops. I've got a red line. Don't want that. I've got my horizontal line here in green. And if you remember with functions, in order for them to have an inverse, they have to pass the horizontal line test. So I've just got a little horizontal line. And you can see right here, it crosses at, well, more than 1. It actually is going to cross at 4 points, unless you get all the way up here to the top where it's 2, all the way down here to the bottom where it's 2. It'll cross at 2 or 4 points. At any rate, more than 1 point. So in order to overcome that, what we have to do is create a restricted domain. And we had talked about this earlier in class. So in order to restrict the domain, let's take a look. I've got a little animation here. And what's going to happen first is we're going to draw a sine wave in blue. And then after that, we're going to draw just a section of the sine wave in red. And the section of the sine wave that we're drawing is going to allow us to pass the horizontal line test. And when you select a portion of a trig function for an inverse, you always want to have 0 in your restricted domain. So in this case, the restricted domain is going to be negative pi over 2 to pi over 2. But as you can see with this animation, we'll go on to the next screen. With this animation, if you look at the red part of this graph, you always pass the vertical line test from top to bottom. Now, the domain is negative pi over 2 to pi over 2. So this is negative pi over 2, pi over 2. And the range goes from negative 1 to 1. So what's important when you are looking at an inverse function, what's important is you're going to flip the domain and range. The input becomes the output, and the output becomes the input. So when you have a sine wave, the input is the angle in radians, and the output is the ratio of opposite to hypotenuse. So input is an angle, output is a ratio. So when we go to do an inverse function, we're going to flip that. The input is going to be the ratio, and the output is going to be the domain. So let's look at an animation. And first we're going to draw the whole sine wave so that you can see what a sine wave looks like. Then in red, we are going to have the restricted domain, which is negative pi over 2 to pi over 2. I've got a typo down here. That should be pi over 2. I'll fix that real quick while this is drawing. I think I will. Oh, come on. There we go. I will go over here and we'll put the P in there. That's an O. We'll put a P in, and then we'll stretch this out. Okay, so what we drew up here, the red part is the restricted domain, which goes from negative pi over 2 to pi over 2 with a range of negative 1 to 1. And the green is the inverse function. So let's go away from the animation and let's go over here and draw. So for the inverse function, so for inverse sine, we've got a domain of negative 1 to 1 and a range from negative pi over 2 to pi over 2. And that's what you see in green. The domain goes from negative 1 to 1, and the range, negative pi over 2. Pi over 2 is a little bit outside of this, but if you have the domain and range of the function, then you can get the domain and range of the inverse. Range of the function becomes the domain of its inverse. Domain of the function becomes the range of its inverse. Okay, so that is just a quick look at the inverse of a sine wave. And how it looks, it's important mostly that you have in your mind the red part of a sine wave. And if you know how to draw a sine wave, you know that you want to include 0 in the restricted domain, and then you see how far you go each way until you repeat yourself. You'll end up from negative pi over 2 to pi over 2 with a range of negative 1 to 1. Once you get that, then you can come up with the understanding of the inverse sine. And this green curve right here, you will not have to draw that. There are a couple of homework problems that ask you to draw inverse functions. We're just going to skip those. We're not going to draw the inverse functions. Okay, now we're going to look at cosine. And cosine, again, you have the same thing. It's going to cross at 4 points or more till you get up here to the top or you get down to the bottom. And remember I said we wanted to, when we restrict the domain, we wanted to include 0 when x is 0. So we're either going to have to go this way or go this way. And let's go to an animation. And drawing this animation will show you the restricted domain of inverse cosine. So in red now we have coming up the restricted domain, and it's going to be from 0 to pi, and the range is going to be from negative 1 to 1. So now that we have that animation, let's go ahead and look at this, and the red portion passes the horizontal line test. Now, if you thought the inverse sine function looked kind of funky, the inverse cosine is just the weirdest looking thing going. So again, we're going to draw a cosine wave in blue. We'll draw the restricted domain in red. We'll draw a black line that is the x equals y, which is what the inverse reflects across. And then let's look at this weird green thing. Now, why does that draw the way it does? Well, first, when you look at, I need to select OK. When you look at the inverse cosine, so we'll go up here to cosine inverse. The domain is going to come from the range here, so it will be negative 1 to 1. And then the range, this range looks weird, but the range goes from 0 to pi. And for the original cosine function, when x is 0, y is 1. So when y is 0, x is 1. And then down here, when x is pi, y is negative 1. So when x is negative 1, y is pi. And I hope you can kind of see how this reflects across the black line and comes up over here. But that is how you would understand inverse cosine based on being able to draw cosine. I guess I already wrote the domain and range there. So domain is going to be negative 1 to 1. Range is going to be 0 to pi. And I'm just talking in this video about the inverse trig functions, domain and range, and how we derive it. I'm not actually going to do application in this video. We will do example problems in class, and Lord willing, I'll get to an example video where we can work some examples where this is relevant, because we'll be using these inverse trig functions. And it's important because as you can see, if you're on the red, that's great. But what happens if you're over here and you have to do an inverse trig function? And we'll get to that. It gets a little bit confusing, so you have to be able to understand domain and range for all of your inverse trig functions. And I recommend that before you try and work the problems, you write down the domain and range of the restricted, in this case cosine, so that you can write the domain and range of the inverse trig function. Now the input for inverse cosine has to be between -1 and 1, and the output will be between 0 and pi. So if you think back to the unit circle, that will be in the first and second quadrants. So we will need to, just like we restricted the domain here, we will need to go beyond the domain over here to answer problems as we cruise around the unit circle and do some other things. Okay, here is tangent, and I'm not going to belabor this. Can't pass the horizontal line test. So what are we going to do? We are going to restrict the domain. So just as I've done with the other two trig functions, we will draw a bunch of tangent waves in blue, and then we will restrict the domain in red. So if you look at this red part that we have defined, we now pass the horizontal line test. The domain, -pi/2 to pi/2, and the range is all real numbers. I couldn't type in infinity in this, it just didn't work out. So rather than -infinity to infinity, I have all real numbers. So this tangent function almost looks like f of x is equal to x to the third. Almost. But now I'm going to erase that because it really doesn't. It really is inverse tangent, which we're going to get to with another animation. So let's look at this animation and see how once you have, and this one I just drew one tangent, I didn't want to draw tons of them. We're going to reflect across this black line here, and that looks kind of like a cubed root, which is what you would expect because x to the third, the inverse, is the cubed root of x, so it kind of looks the same. So guess what? When you have inverse tangent, domain is all real numbers, and range is -pi/2 to pi/2. And again, I can't stress enough with the inverse trig functions, the input is the ratio, the output is the angle. And because we're looking at, this is the first quadrant and the fourth quadrant, the inputs over here are in the first and fourth quadrants. So the output of the inverse tangent, the output of inverse sine are in the first and fourth quadrants, and the output of inverse cosine in the first and second quadrants. So we're actually going to talk more in depth in the next video about how to do this. So again, domain is all real numbers, range is -pi/2 to pi/2.